Hello friends, my name is Manoj Kumar from Corp IT. In today's video, we'll discuss about one of the important concepts that is known as compression. We'll also talk about the algorithm that we use for the compression. We took two example how the compression happened at a file level. Let's suppose you have a text file, how the compression happen over there, and if you have an image, how the compression work over there. If you have a three-tier application, how the compression work over there, and some best recommendation that you can follow for your application for the compression perspective. So let's just dig deep into it. Okay, so what exactly compression is in a layman, if you can say. So let's suppose if you have a file of 10 GB, okay, and you somehow converted that file to a 8 GB file using archival method like tar and having it into .zip. That's basically known as compression. Now let's just understand what are the type of compression. If you understand what are the type of the compression, that then we can look into how the compression work. So now let's just understand. Let me type it over. Types of compression. Okay, so there are two type of compression. The first one is lossless and lossy. So what are the lossless and lossy? Let's just understand. So there's a data that you don't want to degrade in the sense you cannot compromise on the quality. If you don't want to compromise on the quality, always go for the lossless compression. If there is some data and you okay if the quality is bit less, what exactly I'm getting, I'm still totally okay with that. I don't want, for me the spaces matter a lot rather than the quality of data, then you can go for the lossy. But for you the quality matter a lot, space is still a second perspective for you, then go for the lossless. Now you can ask Manoj, what are the format that we have in the lossless and the lossy? Okay, so for the lossless we have what exactly like the dotted so for the lossless we have zip, your image format PNG, and you have your music format FLAC. Okay, so those are the like the lossless compression. The quality that you are getting out of here, it's top notch. You still get the benefit of the zip like the compression, and you are also not degrading on the quality perspective, but still compared to lossy they are still bigger in the size. Okay, now let's just talk about the lossy. What are the example we have in the lossy? We have JPEG. It's a great example of the lossy compression. What else we have? We have MP3. What else we have? We have MP4. So these are the primary example for the lossy compression. Okay, now let's just come into our first demo. So in this demo we'll see if we have a text file, how the compression happen over there. Compression. Okay, that's good. Let's just write it. So let's suppose there is a file. Oh my bad, I need to just delete it. I need to have pencil. Okay. Why it is again coming like this? So you have a file, it's a text file a.txt. okay, let's understand how can the compression could work over there. Okay, let's just type a string over there. Okay, I love compression. Okay, now let's just understand the pattern that we are having this particular string. So we have I at a 2 place. Let me just change the color so it will be easy. We have I at a 2 place, so we can type I into 2. What else we have? We have 2 s's, s into 2. What else we have? We have 2 o into 2. What else we have? We have e into 2. Anything else that is coming up? I don't think so. So that's how the compression work at a file level. So if you have a big file, here we are taking a very small string. back you have a very big text file. There we this repetition can be happen multiple times, probably like lakhs or thousand times, most probably in some cases. So what we can make sure, we can how we can make it, let's suppose we can give an index to that. How we can give an index in a file system? Let's just think it's a 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. I know it's got crank up, but yeah. So we can mention that we have I at O place, and also okay, I at O place, and what else we can mention? At a 13th place you can refer to this 0. So when the data can be the file would be uncompressed, then what happen? It just simply refer, okay, whatever the content I have at this place, it's referring from this place. So at that particular place, what exactly the data is, I need to just have it. So that's how the compression works at a text file level. Let me just remove this a bit. Okay, so this look good. Now let's just talk about how exactly it happened at a PNG. Okay, so the what exactly the second example is, oh my bad, I need to just reduce the size. Quality should be this should be small. Image. So if we all know, images consist of a whenever the image is, it is, let's suppose this is the image, there are lots of pixels in every image. Okay, so let's suppose in this particular there is a red with the same color code. In this pixel also we have the red in the same color code. In this pixel we have the red in the same color code, and this pixel we have the red in the same color code. The pattern is forming. We can again mention that we have the red into 4. We can specify the position. Okay, at this particular position, this red with this color code is there, and this particular code, the red is there with this particular code. That's how the pattern form, and that's how we can compress an image. So I believe now you can understand how the compression work. We also took 2 file example, like one the image and what is the text file. Now you can also ask Manu, how exactly it happened on a video. Okay, so let's just do third example, video. So if you all know what exactly the video is a 60 frame, let's just taking a standard example of 60 frame per second. So in a second we have how many frame? We have 60 frame, 60 fps. So what exactly it mean? 1 frame per second. Oh sorry, it's just a fraction, probably like a 1 ms or something. I'm not that good on that. So at a fraction of a 60 second we have 1 frame, and what exactly the 1 frame is? 1 frame will be an image, and we can apply the same logic over there, and that's how we can compress a video also. So we already discussed about 3 major things, like how we can do compression of the image, file, video. Now why you can ask me like, Manu, why it is important, why we need to do for the compression. We need our data in the way that it should be. But when you work in a real life scenario, so it will provide us a storage efficiency, because at the end of the day storage require cost. It will be bear from your service provider or like the one who is account for that project. So that the reason they want the efficient way to store their data. So that the reason compression also. What another thing that it could do? Cost saving. First of all, you are efficient saving your data. Another thing, you are doing the cost saving. Another thing you can do, improve performance. And now you can ask me how it improve performance. Let's suppose you have a web based app. Let's suppose, think about our LinkedIn, okay, and there all the image that we post it on a like a lossless compression. think of, let's suppose we took a image of a 10 took an image from an iPhone that size is around like a 10 MB or something, and if you post over there, then you can think of it like how long it will take for that 10 MB file to be loaded on the web browser. Like the experience for the customer will be so bizarre, so that we don't want. So that's the reason it improves the performance at the UI perspective also. Okay, now I will attach an my link, the article for this thing, so you can go into in depth about that to learn further more things that I'm not covering on this video. Okay, now most of us are working in a 3 tier. In any project that where we are working mostly with the 3 tier architecture. Okay, so now we'll discuss how the data is stored in a 3 tier architecture. Okay, so let's just give a heading: 3 tier architecture. Okay, oh, it's going out of screen. Let me just make it here. So we have a a bit small, let me just clear it up. So we have a VM, we have a networking, we have a storage. Okay, we have a 3 tier. So these are the 3 tiers. Now why we need to be compress the data and each and every layer. Like ideally it's not recommended to compress data in each and every layer. We'll also discuss about the efficient way to compress the data and which layer it is always advisable. So when we talk about the VM perspective, so how we can do the compression. So in this case the classic example is snapshot and the backup. If we can compress those will be really grateful. In the VM, if you have a low bandwidth, if you have a very low bandwidth in your entire network, if you compress the data over there, that's also a good thing for you. So there we can do the compression. Here we can do the compression. At storage, we can do at the file system level. We have something like ZFS. In ZFS we can do inline compression. So that's also a good thing that we can do. Now let's just understand few use cases why we need to do the compression at which level, at which layer, and why. Okay, let me just clear the screen a bit. Okay, I'm just moving it everything over there. So not this one, and the another one is yeah. Just to give a heads up, I'm just having notes over there for reference. That I'm just seeing on that screen also. Okay, so now let's just understand why we need to have all those things and where exactly is very efficient. So you can think of it, if you're doing at a VM level. Okay, let's suppose you are, let me just call it a bit, if you are doing at a hypervisor level, not that one, let me just draw a bit. If you do at a VM level, that create a CPU overhead, and that will create a performance bottleneck. Okay, that's the one issue if we do at the hypervisor level. And if we do at the performance level, or sorry, at the network level, that will also create a issue, because that will create a latency. Then in an ideal scenario, we all like the best, how should I put it, the journal and the best recommendation is to have it as a storage level. And in storage level, how exactly it happen, that's also understand. So when the data is stored, when this data is stored on the storage system, after that the compression take place. Now you can ask me, Manoj, why exactly it happened. We can like have the data, we can compress it first, and then we can store on the on that. That will also create a latency for the system. So when in a 3-tier architecture, what happened? This is a host, this is a VM, this is a storage system. So it will send a packet, and until the packet is stored in the disk, it will not share the acknowledgement. Ideally, whenever it hit on a cache level itself, it will send the acknowledgement to the VM that data is stored in system and you can send me the next packet. So to avoid that, what exactly we do, when the data is stored, then we do the compression and then we stored it. So that's how that's how it happened in most of the cases. In some cases, what happened, like when the data hit to the storage layer, when the data is in cache itself, it's not still written on the disk, it will do the compression and then it will store. So that's, there will be some delay over there, like it is comparatively slow, but it's also a good approach based upon the your organization or your application need. You can think of a thing, you can think for a choice and you can go like that. Now what are the journal recommendation? Let's just talk about those also. Let me do a bit over here. So you can say, Manoj, we can do idly compression at any level, but the ideal is to have a single layer compression. Oh my bad, I need to do it a bit over here. I'm still very new to this, like how exactly both the things are mapping, so that's the reason it is going up and down. So this is a single layer compression, and we have a multi-layer compression. So if you need efficiency in your whole application level, then go for a single layer application, and that too at the storage level. And if it is necessary to have that much of a compression at every stage, or your application demand that, then only proceed with the multi-layer application. But in an ideal scenario, just go for the single layer compression, that too at the storage level. So yeah, that's all for this short video. I hope you like it. I will also attach this video in the description, so it will be easy for you to refer later on. I will also, I believe I also created a deduplication video in the past. I will also attach that. So after that, if you want to know more about the deduplication, that's also a similar concept with the compression, you can also go ahead and watch that video. So that's all for this video. We'll see you in the next one. Till the time, peace.